Professor Patricia Terry. I'm here today to talk to you a little bit about the field of chemical engineering. Specifically, what are chemical engineers? Where do we work? What types of things do we do? And if you're interested in becoming a chemical engineer, what is the right course of study for you? So to get started, chemical engineering is a branch of engineering that uses chemistry, mathematics, biology, engineering fundamentals, and physics to efficiently produce, design, and transform materials and energy. So what does that really mean? Basically what it means is that any goods or products that you use in your everyday life that are mass-produced at some point in time involved a chemical engineer in making them. For example, chocolate bars, candy bars, all kinds of processed foods like Lay's potato chips, Coca-Cola and other beverages are produced by chemical engineers in processing plants where we have the ability to make thousands or millions of gallons at a time of a product. Chemical engineers go to work in the plastics industry, making all different types of polymers and plastics that are used for plastic bottles, that are used for packaging, that are the urethanes that are used to make foams. Chemical engineers work in the pharmaceutical industry. One of the things that they do is new product development for new medications to help people with specific diseases, especially in terms of slow-release medications that will last for 12 to 24 hours in the human body. We work in the agricultural field, making fertilizers and pesticides like the Scotts fertilizer that we see on here. We work in the textile industry, so a lot of modern fabrics that we use come from petroleum derivatives like our polypropylene fabric and rayon fabrics, and chemical engineers help mass produce those. We work and make synthetic rubbers that are used in the tire and automotive industry. We work and help mass produce paints and different types of coatings and sealants. Chemical engineers work in the semiconductor industry, not actually making the microprocessors, but in making the silicon chips that the microprocessors are built upon. And the very earliest days of chemical engineering actually involved the production of alcohol. So in the petroleum industry, you hear of distillation columns, and chemical engineers work to design distillation columns that refine crude oil into the different grades of petroleum and motor oil that we can purchase for vehicles, but also in the production of different alcohols. So the very, very first ever application of chemical engineering was in building stills to distill alcohol from different farmers, people that made homebrew alcohol. That eventually grew into the greater industry that serves across all spectrum, again, of processed and manufactured goods that we use. Okay. So some of the industries, as I said, that you'll find chemical engineers working in: the traditional chemical manufacturing field. Chemical engineers work in petroleum refineries in the field of hydraulic fracturing to separate the crude oils that are produced into the different refined oil and gas products that we need. Chemical engineers go to work in the pharmaceutical industry, in the textile industry, across all levels of food manufacturing, especially if you go to the processed food aisles where you get your potato chips, your cookies, your boxed cake mixes, different drink beverages. All of that involves chemical engineers. We also work in the environmental industry in terms of remediating contaminated water or contaminated air. Chemical engineers, again, work in the nanotechnology and semiconductor and electronics industries, making the silicon chips on which semiconductor electronics are embedded, and also in the renewable energy arena, producing photovoltaic cells, which are also silicon-based. Okay. So just to break down some of the different industries a little bit further, industrial chemicals include everything like detergents and soaps. So all of the hand sanitizers that are very popular right now with the need to avoid getting COVID from your Tide powder and liquid detergents that you use to wash your clothes, to the detergents and soaps that you use to wash dishes and your dishwasher, to hand soaps and shampoos that people use. We mass produce plastics and urethanes, from plastic bottles to plastic films, and urethanes for foams that are used in couch and chair cushions and mattresses. Chemical engineers work in the agricultural field, producing fertilizers and pesticides to maximize crop production. We work in the paint and coating areas to make more high quality paints, things like the easy to wash, waterproof paints, coatings, and sealants that people use. We also work to make metal alloys. So not only do we produce the Coca-Cola, we also help to produce the aluminum alloy that the can is made out of, and also different metal alloys for steel cans and other types of products. Chemical engineers work in the cosmetic industry, making different makeups. A lot of those are petroleum-based products. And a lot of these are made by some of the major companies in the industrial chemical area. Dow Chemical in particular has huge plants that have different blocks that work in all of the different industrial chemical areas. Big companies like DuPont and companies like Procter & Gamble that make your cleaning supplies and cleaning agents. Okay. Again, chemical engineers work in the environmental arena, primarily looking at two different areas. Pollutant reduction. So if you can alter an existing process to not make a pollutant, then you've saved yourself a job down the line of having to remediate, store, clean up, and treat that particular pollutant. When that's unavoidable, chemical engineers design different separations processes to purify water, to purify air, and in soil remediation. So, for example, all water is purified before it comes out of the tap in your house for you to drink. And the different steps in water purification to remove solids, to remove pathogens, if you've got water contaminated with heavy metals, anything to remove that. All of these things are done by unique separations processes. The same thing for air purification. In order to remediate the problem of acid precipitation from coal combustion, all modern coal-burning electric power plants have scrubbers on them, and the scrubbers react any sulfur dioxides out of the airstream before the airstream exits the plant, so that that sulfur dioxide then does not have an opportunity to interact with the atmosphere and produce acid precipitation. We also work in the area of soil remediation, where you might have oil spills or other contaminants that get into soils that need to be recovered and restored. We also work a little bit in the renewable energy industry, again, making photovoltaic cells and mass producing them. Okay. So chemical engineers work in the biotechnology and pharmaceutical industry by creating new drugs using enzymes and microorganisms and applying organic chemistry and organic synthesis to create new drugs, new medications to treat a myriad of different diseases. A lot of work is done by studying what a medication does after a person ingests a tablet. And let's say that you are either getting insulin injections for diabetes, or you're taking an allergy medication that you need to last 12 to 24 hours. Chemical engineers understand the transport of that medication throughout your body and throughout the system so that they can best design medications that will last over an extended period of time after an injection or after a tablet has been taken. A lot of new drugs and medications now come from things that are natural in nature, but there's not enough of those natural products to produce medications people need. So chemical engineers work with chemists to synthesize new drugs that mirror the natural products. We also create new materials, whether it be plastics or metal alloys, to make prosthetics for people who are disabled or who are potentially military veterans who have lost a limb. So different industries that employ chemical engineers are drug companies like Pfizer and Merck. Okay. Any place that you have mass production of foods, especially the processed food industry, employs chemical engineers. When I was an undergraduate, I had the opportunity or was offered a job by the Mars M&M factory, and I always thought people would really like you if you made M&Ms or candy bars for a living. So we work to make, again, anything that's mass produced on a huge scale, from mixing the raw materials that make the chocolate to extruding the chocolate into the chocolate bar with the Hershey's stamped on top of it, to then packaging and wrapping that chocolate bar to get it ready to go on the grocery store shelf. All of these things are done by chemical engineers. We work again in the wine and beer and alcohol industry. We work in cheese manufacturing, where you're looking at enzymes reacting with milk to produce cheese in large quantities. Any type of box food or food mixes like cake mixes, cookies from the grocery store, all of these things involve chemical engineers. So the entire array of the food processing industry, including companies like Kraft, Coca-Cola, Nestle, all employ chemical engineers. Okay. So one of the questions I'm most frequently asked is, what is the difference between a chemist and a chemical engineer? A chemist frequently works in a lab, and they do the initial testing and the initial product development on a very small scale lab basis. Now at the higher levels, research engineers and research chemists will work together in the lab to make and develop new products on a very small scale. Chemical engineers then design the bigger processing plant that makes that product on an industrial scale. So instead of making 8 ounces of a shampoo solution, chemical engineers go to work in a plant that produce 16-ounce bottles of shampoo on the order of thousands of gallons per day or more. Okay. So some of the different emphases within chemical engineering that a person can go into are the process control industry, where you look very specifically at how does a plant operate. in order to make a given product that involves a chemical reaction, how do you feed the right quantity of materials into a reactor so you're controlling process flow rates? Within the reactor, you're controlling the temperature, so you'll have coolant solutions to cool down an exothermic reaction. So how do you regulate the temperature in a reactor and regulate the cooling solution to maintain a desired temperature? Again, how do you monitor pressures within a big chemical manufacturing facility? So chemical engineers who are really good with mathematical modeling can go into the process control arena and learn how to develop the algorithms and work with flow meters, pressure meters, temperature meters to optimally run the chemical plant. A lot of chemical engineers now are going into the environmental field because very specific chemical engineering separations like adsorption, absorption, distillation, filtration, membrane separation, all of those processes are understood and designed by chemical engineers who then can apply those separation processes to remediate contaminated water, soils, or air. Chemical engineers can specialize in kinetics and in reactor design. So a lot of the products made by chemical engineers on an industrial scale require chemical reactions to transform two different materials into a desired product. All reactions happen at different rates. Some reactions give off thermal energy, some reactions require thermal energy. So people who study the field of kinetics and reactor design look at how to design a reactor, how to design a cooling system or a heating system so that you optimally make your product without having a system overheat. Again, the separations industry, some of that applies to environmental separations, but some of that applies just across the board in chemical engineering. So often when you make a product via a chemical reaction, you make your desired product with at least one or two other products that you don't necessarily need or want in the final marketed process. So a chemical engineer with a specialty in separations knows how to take a particular product stream and separate out the desired product from the undesired materials, and then either appropriately dispose of the undesired materials or recycle those back through the process to optimize how much material you're manufacturing without requiring new raw materials coming into the system. Because chemical plants involve a lot of piping and valves and different feed rates and flow rates, the study of fluid dynamics is very important so that we can design pumping systems that will transport our raw products and our final products through a greater chemical plant. Engineers can also go into mass transfer. So again, as we talked about with the pharmaceutical industry, when you take an aspirin, you're looking at how does that aspirin dissolve in the stomach, how is that medication absorbed by your body tissues and transported throughout the body to the area that is in pain, and how do we design a tablet to make that pain reduction property of an aspirin last as long as possible. So mass transfer in the study of how materials are transported throughout a human body or across a membrane barrier are very, very critical to the chemical engineering field. And then finally, for the very mathematically inclined who go into chemical engineering, all processes have to be modeled, especially newer processes in research, product, and development. Okay. So The job market for chemical engineers is really strong, and it's one of the most resilient job markets out there just because of the enormous range of industries that chemical engineers work across. So according to the current U.S. Bureau of Labor Statistics, there's going to be an employment growth rate of about 6% between 2018 and 2028. So there's going to be a continued societal need for chemical engineers from the bachelor's level all the way up to the PhD level, where you can go to work in process research and new product development. The average starting salary for chemical engineers is very attractive. It's a little over $73,000 a year, and the median salary in 2019 was well over $100,000 a year. Now, granted, this includes people who have been in the job for 20 plus years and often move up into management positions, and people who have pursued graduate degrees in chemical engineering. At the bachelor's level, the average starting salary is still in the very high 60s up to that $73,000 range that the Bureau of Labor Statistics is reporting. So one of the reasons I decided to become a chemical engineer many years ago is I was in high school, and at the age of 17, my life aspiration was to make a lot of money. Well, I knew that I was very good at mathematics, and I knew that I was very good at chemistry, and I liked both of these subjects in school, so it made sense to put these things together and study chemical engineering and guarantee myself a high starting salary. Okay. So finally, chemical engineering, are you interested in this field? There's a lot of diversity within the field. As we've already stated, there's a lot of specialties within the field that you can go into, but things you should think about in terms of studying chemical engineering. Okay? Types of courses that you're going to need. A bachelor's degree in pretty much any field of engineering is going to require a minimum of 3 to 4 semesters of calculus, including differential equations and multivariate calculus. In order to go into modeling and process control areas, you're going to need a good background in statistics. Obviously, chemical engineers need to have a strong background in chemistry. So in order to earn my bachelor's degree, I had to take 2 semesters of basic fundamental college chemistry, 2 semesters of organic chemistry, and 2 semesters of physical chemistry, and all of these classes had labs. The combination of calculus and chemistry get you ready to take thermodynamics and kinetics and reactor design, where you learn about is a reaction exothermic where it gives off heat, is it endothermic where it needs heat, so you can properly design a system to have appropriate cooling and or appropriate heating to make a reaction occur but not go out of control. Chemical engineers take classes in mass transfer and in heat transfer, which draw off of multivariate calculus and thermodynamics. We take classes in process control that require some more additional advanced mathematics. And then we take classes where we learn about what are the different separation processes. So how does one design a distillation column to distill crude petroleum and to everything from aircraft grade fuel to the gasoline that we put in our cars, to the heavier residual tars that are used to pave roads. So there's a lot of different separations processes that can be learned, and there's new research going on all of the time in all of these fields. Okay. So that's the basic fundamental of what somebody does with a degree in chemical engineering. If anyone has any questions, your professor can direct you towards me. You can send me an email if you have more questions or you want more information on where to go to get a degree in chemical engineering, what classes you should be taking right now, and any other questions that you might have. So thank you for hearing me.